Unit 1 Review, Problem 2. The principal at Tahoe Elementary School randomly selected 3 of the school's 12 classes of students to participate in an opinion poll. All of the children in each of the 3 randomly selected classes were asked the question, "What is your favorite fruit to eat?" The following results were obtained. Part A. Identify the method of sampling used to collect this data. So far, we've studied 4 basic types of sampling methods: simple random sampling, stratified random sampling, cluster random sampling, and systematic random sampling. We've also discussed this idea of multi-stage sampling. Multi-stage sampling is where we have multiple steps of the sampling process in which we use combinations or more than one of these different various methods of sampling. So here, to determine which one, we have to know what each of these methods of sampling do. Recall, the simple random sampling method takes a sample from an entire population and applies some random process to ensure that every sample that would be selected from this population would have an equal chance of being selected. The stratified random sampling method takes the entire population and breaks it up into natural subgroups. Then a random sample is selected from each and every one of the subgroups. Cluster random sampling takes the entire population and breaks them into natural subgroupings. But here the random selection is done to the groups. And then whichever of the subgroups are randomly selected, each and every member of that subgroup that was randomly selected is then included in the sample. Systematic sampling is done where the population is put in some random order first. Then you systematically go through and select every so many one through that population. For instance, you could select every 5th one or 10th one as you go through the population to conduct your systematic sample. And as mentioned before, multi-stage sampling has multiple steps in the sampling process where we apply one of these basic sampling methods in each step as we go. So first step, you could apply some stratified random sampling, for instance, but then a second step employs some sort of systematic sampling, and so on. So here we looked at this particular problem's method for collecting the sample. Here, the principal at Tahoe Elementary School randomly selected 3 of the school's 12 classes of students to participate in an opinion poll. So the populations of students at the school were placed into natural subgroupings, which was the classes the students were in. Here, this school has 12 classes of students. Then the principal randomly selected 3 of the school's 12 classes of students. So out of these 12 classes, the principal randomly selects just 3 of the classes. Then, out of these 3 randomly selected classes, all of the children in each of these 3 randomly selected classes were asked the question to collect this sample. This type of sampling method is cluster random sampling, because the entire population of students at the school were broken up into its natural subgroups or classes. And then the classes themselves were randomly selected. And whichever one of the randomly selected classes were picked, all of the students in that class were included in the sample. This is what a cluster random sampling method looks like. So we have our answer to part A. The method of cluster random sampling was used to collect this data, since the students were grouped by classes and every child in the randomly selected classes was included in the sample. Part B. Construct a percentage distribution table with this data. Well, in order to construct a percentage distribution table, we need to make a table. So a table consists of a rectangular array that is divided up into rows and columns. Now we need to label each of the columns. In a distribution table, the first column corresponds to the data. So here the data that was collected was the favorite fruit to eat of the students. So we label the first column favorite fruit. Then underneath the column title for the data, in this case favorite fruit, we need to list all the data that was collected in the sample. So as we look through the data, we see that students had selected apples, grapes, bananas, oranges, and strawberries as their favorite fruit. In the table, you must include all of the data values that were in the sample. We can't leave any of the data out. So here, our first column of our distribution table is complete. It's titled favorite fruit, followed by all the data which was collected: apple, grapes, banana, orange, strawberry. Now, the second column in the table is based on the information we want to display in the table. Here, the problem says to construct a percentage distribution table. So the information we want to communicate with this data is a percentage. So we label the second column percentage, and then we need to calculate the percentage for each of the favorite fruits that were mentioned in this sample. To calculate the percentage, we need to first find in the total sample size and then count the FX, the frequency of each of those data values. And then once we take the frequency of the data divided by n, the total, we multiply 100 to convert it to a percentage. And then upon rounding, make sure we carry the at least one extra decimal place by rounding the percentage to the nearest tenth of a percent. You could carry more decimal places to be more accurate, but don't go any less than that because we don't want the round-off error to be too big. So starting with the first favorite fruit in our list, apple, next to it we put the percentage of students who mentioned apple in the sample. To do this, we need to find in the total sample size. So that requires us to count each and every one of the data values that were mentioned here. As you go through and count all the different students that provided a different favorite fruit, you'll see that there was an n equals 58 total students in this sample. Then to get the frequency of apples mentioned, you got to then count just the students who mentioned apple. Going through the entire 58 student responses here and counting just those who mentioned apple, you go through and count, and you'll find that 26 of the students selected apple as their favorite fruit out of the total of 58 students in the sample. Calculating the percentage, we would take 26, divide by 58, times 100, and then rounding that, carrying the extra tenth of a decimal place here, we get 44.8% of the students selected apple as their favorite fruit. For grapes, we do the same thing. We go through all 58 students who gave us a response to this question, then counting the frequency, just those who select grapes, we see that 14 of the 58 students in the sample selected grapes as their favorite fruit. Calculating the percentage, we get 14, divide by 58, times 100, and then rounding off to the nearest tenth of a percent, we get 24.1% of the students in the sample selected grapes as their favorite fruit. The percentage of students who selected bananas is calculated the same way. We go through all 58 student responses, counting those who selected banana as their favorite fruit. We see that there were 8. 8 students selected banana as their favorite fruit out of the total of 58. This converts to 8 divided by 58 times 100% equals 13.8%, rounded to the nearest tenth of a percent. For orange, we go through all 58 student responses, count the students who responded orange was their favorite fruit to eat. We see there's 1, 2, 3, 4, 5, 6, 7. So 7 students selected orange as their favorite fruit out of a total of 58. Converted to a percent, we get 7. Divide by 58 times 100 equals 12.1%, rounded to the nearest 1/10%. And finally, strawberries. Out of the 58 student responses we had in the sample, we count and find that just 1, 2, 3 of the students selected strawberries. So the percentage of students who selected strawberries as their favorite fruit to eat in the sample is 3. Divide by 58 times 100%. Enter, round it off. Carrying one extra decimal place, we get 5.2%. So now we have constructed our percentage distribution table for this data. But remember, any graph we produce, we need to include a title. The title must include 2 things. 1, what is the data? And 2, what was the population the sample was selected from? This is very important to include this in the title because the title gives the reader of the graph the context from which this data came from. This will allow them to be able to interpret what's going on. So the data here selected was the favorite fruit to eat, and the population for which the sample was selected was students attending Tahoe Elementary School. So an appropriate title for this percentage distribution table could be the favorite fruit to eat of children attending Tahoe Elementary School. So here's our complete answer to part B. We constructed the percentage distribution table with this data. We provided a title for our table. We labeled each of the columns clearly and listed all the information underneath each column correctly.